Hey guys, Mr. Milton here. Today we're going to talk about graphing functions. At the end of this video you should be able to graph a function using a table of values. And you should be able to identify the shape of a graph before graphing it. Okay, so we're going to graph each function on the given coordinate plane by plotting at least 5 points from a table of values. Notice they didn't give us a table of values, so we'll make that. And that can be pretty simple here, guys. All we have to do is make our table x, y. Okay. Now this first time, let's explain this. Remember that in our function we have an independent variable and a dependent variable. Okay, independent along with just the regular meaning. Well, kind of the regular meaning will help us understand what that means. Independent means it doesn't matter what anything else is doing. Okay, so if you're independent, you can do things based off of whatever you want to do. Okay, and so x is our independent variable. Y is our dependent variable. Okay, so the reason I'm going into this is because we get to choose the x value. Okay, it's independent of anything else. So we're going to choose numbers that we feel will help us do this or graph the function easily. Typically what we'll do is we'll choose values that are negative, 0, and positive, possible. And that way we can see how the function reacts in a range of values. Okay, so the easiest way to do that, if possible, is just use negative 2, negative 1, 0, 1, 2. Okay, they're independent. Okay, and then what we'll do is we evaluate the function with these values. Okay, and so just like our last lesson, means we're going to plug in our x. So I said f of negative 2. I plug that into 3 times negative 2 minus 4. Okay, and then I just simplify. So 3 times negative 2 is negative 6, minus 4 is negative 10. Okay, and we do that for each value here. We can do that each time throughout this thing. I don't really have space to do it here, but I'll do it on the calculator and try to leave some space so that we can see it happening. Alright, so we can do that same thing here. We have 3 times negative 1, which is negative 3 minus 4. Nope. 3 times 1, and I have to put the negative on this calculator here. Okay, negative 3 minus 4 gives us negative 7. Okay, 0 is nice because there's not a whole lot that we have to do for 0. 0 times 3 is 0. Minus 4 is negative 4. Okay, 3 times 1 minus 4 is negative 1. 3 times 2 minus 4 is 2. Okay, and so there's our function, our table. And so what we'll do now is we'll graph those points on the coordinate plane. Remember that each of these are points. So we have negative 2, 10, negative 1, negative 7, 0, negative 4. Okay, and so negative 2, 1, 2, 3, 4, 5, 6, 7 doesn't fit. Negative 1, negative 7, so negative 1, 2, 3, 4, 5, 6, 7. Okay, so that's the bottom. 0, negative 4, 1, 2, 3, 4, 1, negative 1, 2, 2. Okay, so there's my function. I will make a line through here. Try to at least. Okay, so straight line, function there. Okay, what shape is this? It's just a line. Okay, and so we can do the same thing for the other values as well, or the other functions as well. And so we'll make our table just the same way. X here, Y here. Nothing's really stopping me from using these values, negative 2, negative 1, 0, 1, 2, so I'll use those values. Plug them into the function. And so I have 1 minus, and then I'm going to put this in parentheses, 2 times negative 2. And so 1 minus 2 times negative 2, remember that 2 times negative 2 will be negative 4, so 1 minus negative 4 would be 5. Okay, do the same thing here. 1 minus, and I'll put this in parentheses just so it works out, 2 times negative 1 in parentheses. Okay. Nope. 1 minus 2 times negative 1. There we go. Alright. And that gives us 3. Alright, the 0 comes in, so that makes it easier. 1 minus 0 is just 1. Okay. And we have 1 minus 2 times 1, so 1 minus 2, which gives us negative 1. And usually by about the third time with these linear ones, and we'll talk about how we can tell they're linear, we can kind of see the pattern happening each time we are decreasing by 2, decreasing by 2, decreasing by 2. Once that pattern's established, it's pretty, excuse me, it's going to be consistent there. So there's our answer, our table. We plot those points, negative 2, 5, negative 2, 1, 2, 3, 4, 5. 1, 2, 3, 0, 1, 1, negative 1, 2, negative 3. Okay. Should be a straight line. I'll use my straight edge to try to. Alright. Again, it's a line. Alright. So now the question might be, when would we. So you said that negative 2, negative 1, 0, 1, 2, x is independent. When will we choose other numbers? Well, we're going to choose other numbers here. And the reason that we would choose other numbers is if there's anything that would make it difficult by choosing these numbers. And so if you look at number 3, you should notice that we have a fraction for number 3. We have f of x is 1/2 x. Okay, if I chose negative 1 and 1 when I multiplied, I'd have a fraction, which isn't a terrible thing, but it's going to be hard for us to accurately graph a fraction. And so what we're going to do to avoid that is, instead of choosing odd numbers, is I'm going to choose numbers that are going to be even, in this case even, because I want to make sure that they're multiples of the denominator. Okay, so instead of choosing negative 2, negative 1, 0, 1, 2, I'll choose negative 4, negative 2, 0, 2, 4. And what that does is it ensures that whatever number I use will come out as a whole number. Okay, so 1/2 times negative 4 gives me negative 2. 1/2 times negative 2 is negative 1. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 4 is 2. Alright, and so then I can use those values. 0, 0, 2, 1, 4, 2, negative 2, negative 1, negative 4, negative 2. Alright. Again, I'll draw my line, just using the straight edge to try to keep it neat for you, the graph and you guys visually. Okay, again, it's a line. Alright. I want you to try number 4 on your own. I'm going to help you set up the table though. Okay. So remember that we're going to use these x values, and so we get to choose our x values. In this case, our denominator is a 3. Okay, so we won't choose even numbers because, again, we want to make sure that we don't come out with a fraction as our answer. So we're going to choose multiples of 3. So you can choose negative 6, negative 3, 0, 3, 6. Okay, fill out that table and then plot that graph here. Okay, I'm going to help you out and tell you that this should come out to be a line. Okay, and just like in our first problem, notice that we had the point negative 2, negative 10 that didn't fit our graph. Well, that's fine. If it doesn't fit our graph, then we just don't plot it on the graph. We plot the points that we have. Okay? Alright. So, notice how we chose negative 2, negative 1, 0, 1, 2. Okay, Okay, we already kind of talked about that as the x values for problems 1 and 2, but for problems 3 and 4, we chose different values since those have fractions being multiplied into the variable. Okay, so we've already talked about that, just kind of drilling that home. To get clean numbers, we chose multiples of the denominator. Again, we've talked about that. This is just writing it down so you have something to reference for that. All 4 of these problems made a line. And you can tell that it's going to make a line if you just have x by itself. And we'll look at some different functions that show you what I mean exactly by that. But notice there's no exponents, there are no absolute value brackets, and so we can see that x should be and there's no x is not at the bottom of a fraction. Alright guys, so now on the back here we're going to speed it up just a little bit as we look at some other functions and their shapes as well. Alright, so notice I already have the tables filled in, and now we're going to just evaluate these functions with the given x values. See what we get out. So we have -4 plus 2, that'll be -2. The absolute value of -2 is 2. -3 plus 2 is 1, or sorry, -1. The absolute value of -1 is 1. -2 plus 2 is 0. Absolute value of 0 is 0. -1 plus 2, absolute value of that is 1. And 0 plus 2 is 2. So there's our values. All of our points, so we have -4, 2, 1, 2, 3, 4, 2, -3, 1, -2, 0, -1, 1, 0, 2. And so then our shape will be a V. Alright. V shape here. On the other side, continuing on, we'll do the same thing here. Plug in our values. Notice that there's a negative outside of the parentheses, so when we do our absolute value, we will actually get a negative number. So 2 times -2 will be -4. Absolute value of -4 is 4, but then we'll have -4 plus 3. So -4 plus 3 is -1. Do that same thing. 2 times -1 is -2. 2 plus 3 will give us 1. 0, so that makes it easy. That's nice. Okay, do the same thing with 1. That actually brings us back here. 1 times 2 is 2. -2 plus 3 is 1. And then same thing with 2. That'll give us -4 plus 3, which will give us -1. Okay, so again we have those values 0, 1, 2, 3, 1, 1, 2, -1, -1, 1, -2, -1, and so we have this upside down V. Still a V shape. I'll say it's a V shape. Okay, now looking at the bottom 2 graphs here, still doing the same thing here. Plugging in our values. Again, notice that there's a negative out here. So when we square it, and I'll write this first one out for us, we have -2 squared plus 5. So -2 squared will give us 4, but then there's a negative out here, so it'll be -4 plus 5. So -4 plus 5 gives us 1. Okay, do the same thing. 1 squared is 1, -1 plus 5 is 4. 0 gives us just 0, so that's 5. Do the same thing with 1. That'll give us +4. And then do the same thing with 2. And all we're doing here, guys, is we're plugging it in. And I could write these down each time, but I'm sure that that video would be way longer than we want it to be. Okay, so 2 squared is 4, -4 plus 5 will give us 1 again. Okay, and so now we have our values at 0, 5, 1, 2, 3, 4, 5. At 1, 4,
at 2, 1, negative 1, 4, negative 2, 1. And so it seems to be similar to the previous graphs, but notice that the previous graphs, they were just kind of straight lines coming from each side. These are not straight lines. They do not have the same rate. This looks more like a U shape than a V shape. Okay, and it's upside down, but I'll still call it a U shape. Alright, and then our last one, we're plugging in our values. Again, notice that we have a fraction here, 1/2, and so instead of picking the negative 2, negative 1, 0, 1, 2, we're going to adjust that and make these independent values even so that we get an even number out each time. Okay, so negative 4 squared gives us 16. 16 times 1/2 is 8. 8 minus 4 is 4. Negative 2 squared is 4. 4 times 1/2 is 2. 2 minus 4 is negative 2. 0 makes it easy. That's just negative 4. 2 squared is 4. 4 times 1/2 is 2. 2 minus 4 is negative 2. Then 4 squared is 16. 16 times 1/2 is 8. 8 minus 4 is 4. Alright, and so then we graph our values. We're at 4, 4, 1, 2, 3, 4. Okay, at 2, negative 2, 1, 2, negative 2, 0, negative 4, negative 2, negative 2, and then negative 4, 4. Alright. And so there we have it. And our kind of a wider U, but still a U nonetheless. So, U shape. Alright, so for problems 5 and 6, they had a V shape because of the absolute value around the variable. So notice their absolute value that was around X, so that made it a V shape. For 7 and 8 had a U shape because the variable was squared. Sorry. The V shape and the U shape are upside down when the coefficient is negative. So notice that when the coefficient was negative, when the number in front of the variable was negative, then it became upside down shape. Alright, so what I would like for you guys to do for me is these next 4. Tell me what shape these values will be. So we kind of already laid out what the shape should look like, or how we can tell what the shapes look like. So without graphing these, so don't graph them, just tell me what these shapes should be. Alright, see ya.